Now we are going to find the electric field intensity at a point on the equatorial line of an electric dipole. To that we are considering an electric dipole. We already know that an electric dipole has two different charges. If this is negative charge Q, then this is positive charge Q. And these different charges are separated by a small distance is taken as 2a. And this is the center point of this dipole is O. Then the distance from O to this positive charge Q is A. Then the distance from O to this negative charge is also A. Then we are considering an equatorial line of this dipole. The equatorial line of this dipole is passes through like this. The equatorial line of this dipole is passes through the center point of this dipole O. The next step we are going to consider a point P. A point P on this equatorial line. A point P at a distance r from the center O. We consider a point P on this equatorial line at a distance r from the center O, and we placed a minute positive charge at P, a very minute positive charge at P. Then the dipole has two different charges. Due to this positive charge Q, a repulsive force is generated at point P. Due to this negative charge Q, an attractive force is generated at point P. Due to this positive charge Q, the electric field intensity is at point P is in this direction. The electric field intensity at point P due to the positive charge Q is taken as E positive, is in this direction. Like that, due to this negative charge Q, the electric field intensity at point P is in this direction because that's an attractive force. So electric field intensity is in this direction, is taken as E negative. These are the two electric field intensities formed at point P. The electric field intensity due to positive charge is taken as E positive, and electric field intensity due to negative charge is taken as E negative. These are the two electric field intensities formed at point P. Then the distance from the positive charge Q to P is root r square plus a square, because the distance from O to Q is A, the distance from O to P is r. When we apply the Pythagoras theorem, the length of this hypotenuse or distance from Q to P is root r square plus a square. Like that, the distance from negative charge Q to P is also root r square plus a square, because the distance from negative Q to O is A, O to P is r. When we apply the Pythagoras theorem, the length of this hypotenuse is root r square plus a square. Then next we can write the equations of these electric field intensities. Then electric field intensity E positive. The equation of electric field intensity is 1 by 4 pi epsilon 0 Q divided by r square, the distance square. Here the distance is root r square plus a square. So root r square plus a square the whole square. Like that, the equation of electric field intensity E negative is equal to 1 by 4 pi epsilon 0 Q divided by r square. Here r is, or distance is, root r square plus a square the whole square. Next, we want to find the resultant electric field intensity at point P, because there are two electric field intensity, E positive and E negative. To find the resultant electric field intensity, we want to consider the vertical and horizontal component. The vertical component of E positive is in this direction, is E positive sin theta. The horizontal component of E positive is in this direction, is E positive cos theta, because that is horizontal component, E positive cos theta. We wrote like this. If this is E positive, is vertical component is in this direction, is vertical component is in this direction, is taken as E positive sin theta. Is horizontal component is in this direction, is taken as E negative E positive cos theta. This is what we do. The next is like that. We want to find the vertical and horizontal component of E negative. The vertical component of E negative is in this direction. E negative is in this direction and is taken as E negative sin theta. The horizontal component of E negative is in this direction, is E negative cos theta. These are the four vertical and horizontal component of E positive and E negative. The next step, E positive sin theta and E negative sin theta of the vertical components are cancelled out. These two vertical components are cancelled out. These two vertical components are cancelled out because they are in opposite direction. So these two vertical components cancel out. So the resultant electric field intensity form these two horizontal components. Then what is the resultant electric field intensity? Resultant electric field intensity is E resultant. E resultant is the sum of these two horizontal components is equal to E positive cos theta. E positive cos theta plus E negative cos theta. E positive cos theta plus E negative cos theta form the resultant electric field intensity. So what is E positive cos theta? E positive is 1 by 4 pi epsilon 0 q divided by root r square plus a square, the whole square. So root r square plus a square, the whole square, we can write as r square plus a square. R square plus a square cos theta plus E negative. E negative is 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 q divided by r square plus a square, the whole square is r square plus a square, then remaining cos theta. Then write this, when add this we get 2 into q divided by 4 pi epsilon 0 r square plus a square cos theta. The next one we want to find the value of this cos theta. What is cos theta? What is cos theta? If this is the angle theta, this angle is also theta. When apply the parallelogram theorem, this is two parallel lines. If this is angle theta, this is also angle theta. If this is angle theta, this angle is also theta. When we consider this angle theta, then cos theta is equal to, when we consider this theta, this angle theta, then cos theta is equal to adjacent side by hypotenuse. Here the adjacent side is a, here the adjacent side is a, here the adjacent side is a divided by hypotenuse. Hypotenuse is root r square plus a square. So the value of cos theta is equal to a divided by r square plus a square. Then E resultant electric field we get, the resultant electric field we get is equal to 2q divided by 4 pi epsilon 0 r square plus a square, then a divided by the value, when we apply the value of this cos theta is a divided by root r square plus a square. The next step we are applying the value of this 2q into a. What is 2q into a? This 2q into a is 2, or 2a into q is dipole moment. It is dipole moment. 2a into q is dipole moment. Then you write the electric field intensity at point P is E is equal to, when we replace this 2a into q as dipole moment P divided by 4 pi epsilon 0, then r square plus a square into root r square plus a square, can write as r square plus a square the whole raised to 3 by 2. The next we consider this distance a is very less than the distance r, because in a dipole the two charges are very close together, so the distance a is very less than r. So we can avoid the term a from this equation. So we get the equation, when we replace this equation as E is equal to dipole moment P divided by 4 pi epsilon 0. When we remove this term a, then we get the r square the whole raised to 3 by 2 is r cube. This is a resultant electric field intensity at point P. This is a last equation we got. This is a resultant electric field intensity at point P. This is a resultant electric field intensity at point P.